Okay, question 1. It's statics questions. I've got a particle that's attached to one end of a light and extensible string, as you can see in the question. So the first thing I'm going to do, which really do with all mechanics questions, is draw a nice big diagram showing everything and then put in extra details that aren't in the question. So straight line down there. $12 newtons, got P, and that's 20 degrees. And I'm trying to find the tension in a string. So what have I also got on here? I've got mg acting vertically downwards. That is point P. And I've got a tension acting inwards on the string. So the first part, part A, wants me to find a tension in a string. So in order to do that, I'm going to resolve horizontally. And in doing so, that eliminates mg from any calculation. And I'm going to resolve horizontally at P. And I'm going to take to the right as positive. Could be either direction, but I must state which I am choosing as positive. So 12 newtons minus, and it's a component of the tension there. So we'll just put that angle in there, which is 70 degrees, and it's going to be minus T and the horizontal component, which is T cos 70. And that must equal 0 because it's an equilibrium. So T equals 12 over cos 70. So this point's out with a calculator. Make sure it's in degrees, and it is. So simply 12 over cos 70. And I get an answer of 35.09 newtons. There's no involvement of G at this point, so I can keep the answer as accurate as I like, really. We'll leave it at that for the moment. So that's part A. Next thing I'm trying to find is the weight, mg. So I'm going to work from what I know. I'm going to resolve at P, and I'm going to resolve up as positive. So T, this time it's the opposite component, so it's sine 70 minus mg, and it's an equilibrium, so that equals 0. Now it wants the weight, mg is the weight, so mg equals T sine 70. I've already got T, which I've just worked out from the previous, so it's going to be answer times sine 70. Gives me an answer of 32.97 newtons. And that is its weight, which is mg, and probably just round that sensibly to 33 newtons to SF.